Let's say that we have a polynomial p of x, and we can factor it, and we can put it in the form x minus 1 times x plus 2 times x minus 3 times x plus 4. And what we are concerned with are the zeros of this polynomial. And you might say, what is a zero of a polynomial? Well, those are the x values that are going to make the polynomial equal to 0. So another way to think about it is, for what x values is p of x going to be equal to 0? Or another way you can think about it is, for what x values is this expression going to be equal to 0? So for what x values is x minus 1 times x plus 2 times x minus 3 times x plus 4 going to be equal to 0? I encourage you to pause this video, think about that a little bit before we work through it together. Well, the key realization here is if you have the product of a bunch of expressions, if any one of them is equal to 0, it doesn't matter what the others are because 0 times anything else is going to be equal to 0. So the fancy term for that is the zero product property. But all it says is, hey, if you can find an x value that makes any one of these expressions equal to 0, well, that's going to make the entire expression equal to 0. So the zeros of this polynomial are going to be the x values that could make x minus 1 equal to 0. So x minus 1 equals 0. Well, we know what x value would make that happen if x is equal to 1. If you add 1 to both sides here, x equals 1. So x equals 1 is a zero of this polynomial. Another way to say that is p of 1, when x equals 1, that whole polynomial is going to be equal to 0. How do I know that? Well, if I put a 1 in right over here, this expression right over here, x minus 1, that is going to be equal to 0. So you're going to have 0 times a bunch of other stuff, which is going to be equal to 0. And so by the same idea, we can figure out what the other zeros are. What would make this part equal to 0? What x value would make x plus 2 equal to 0? Well, x equals negative 2. X equals negative 2 would make x plus 2 equals 0. So x equals negative 2 is another zero of this polynomial. And we could keep going. What would make x minus 3 equal to 0? Well, if x is equal to 3, that would make x minus 3 equal to 0. And that would then make the entire expression equal to 0. And then last but not least, what would make x plus 4 equal to 0? Well, if x is equal to negative 4. And just like that, we have found 4 zeros for this polynomial. When x equals 1, the polynomial is equal to 0. When x equals negative 2, the polynomial is equal to 0. When x equals 3, the polynomial is equal to 0. And when x equals negative 4, the polynomial is equal to 0. And one of the interesting things about the zeros of a polynomial, you could actually use that to start to sketch out what the graph might look like. So, for example, we know that this polynomial is going to take on the value 0 at these zeros. So let me just draw a rough sketch right over here. So if this is my x-axis, that's my y-axis. So that's my y-axis. And so let's see, at x equals 1, so let me just do it this way. So we have 1, 2, 3, and 4. And then you have negative 1, negative 2, negative 3, and then last but not least, negative 4. We know that this polynomial, p of x, is going to be equal to 0 at x equals 1. So it's going to intersect the x-axis right there. It's going to be equal to 0 at x equals negative 2, so right over there. At x equals 3, right over there. And x equals negative 4. Now, we don't know exactly what the graph looks like just based on this. We could try out some values on either side to figure out, hey, is it above the x-axis or below the x-axis for x values less than negative 4? And we can try things out like that, but we know it intersects the x-axis at these points. So it might look something like this. This is a very rough sketch. It might look something like this. We don't know without doing a little bit more work. But ahead of time, I took a look at what this looks like. I went on to Desmos and I graphed it. And you can see it looks exactly as what we would expect. The graph of this polynomial intersects the x-axis at x equals negative 4. Actually, let me color code it. X equals negative 4, and that is that 0 right over there. X equals negative 2, that's this 0 right there. X equals 1, right over there. And then x equals 3, right over there. In future videos, we will study this in even more depth.